So here's another question that happens all the time. How do you get little bits of density to lie in front of these blotchy areas of flame? If we have little areas of density that are really dark, that's going to help with breaking up these shapes even further. Now, there's a few ways you can go about this, but one way that I like to do it is through the usage of rest fields. So with rest fields in Houdini, it's actually a little bit more complicated if you're using the sparse solver. We need to actually add in all of the gas nodes manually to get rest fields from the sparse pyro solver. So in this video, I'm going to show you how to do that with the idea that we'll use the rest field to create a noise which will move with the movement of the smoke and become extra little bits of detail along these splotchy areas of flame. So before we get on to how to set this up, I want to be sure that we're all on the same page as to what rest fields are, because some of you might have never heard of that before, or you don't know how it works. So let's take a step back and talk about what we're trying to do. Again, we're trying to take little puffs of smoke, place that in front of the hot areas where flame is right now. And if we do that, it'll add a bunch of detail. Okay, so let's say that we add a noise in SOPs. We have little puffs of density. I'll show you how you can add the little puffs of density in SOPs here in a minute. But let's say that we have that. We still have a problem once that's made, and that's the fact that those little puffs that we just made with a noise in SOPs is not going to follow the motion of our pyro simulation. It'll just stand still. And we could try to trick it with the animate noise parameter that I was showing you in the last video. That works okay, but in this situation, it's going to be more noticeable if it's not moving with the actual pyro simulation. It'll look really weird. So the question is, when we generate that noise, how do we take the noise pattern and have it move those splotches with the movement of the pyro simulation? Well, in Shading Techniques 3, I talked about something called the manifold, or the space that a noise lives in. It's basically how noises stick to objects. So if you're not familiar with the concept of manifolds, check out Shading Techniques 3. There should be a link on the screen here that'll take you there. But basically put, we need to feed noises XYZ coordinates so that it knows where to draw the patterns. And so if we want the noise to follow the motion of our simulation, we need to feed it XYZ coordinates that describe the movements of our simulation. And so that's where we need rest fields. Rest fields essentially are just XYZ coordinates that kind of distort over time and describe the movements of the simulation. Just so that you guys can visualize this, here I have a sphere, and what we're looking at is a preview of the rest values. Remember, I said that we are doing these values in XYZ, so we can see that as color right here through this sphere. Now, what's going to happen is that over time, the position or this color is going to be distorted and moved with the movement of the simulation. And that's what we have right here. So if we have a noise and it's looking at these values that are being smudged or essentially evected over time, then they're going to get stretched out. Because if we go back here and we take a look at, let's say, this little patch of green, when the smoke moves, it's stretching out that patch of green. Those values, that position value, is getting distorted over time. And so because of this fact, we need to introduce something called dual rest fields. So the question is, what if we take this whole thing, which again is distorting those values over time, and we cause it to reset itself at a certain point? So at a certain number of frames, this is going to recapture the position in XYZ for all of these areas of density. Well, here's what that might look like. let's go to our Axiom solver and say enable dual rest. If we middle mouse, you'll notice that we have two fields, rest 1 and rest 2. What the frame length is saying is that at every single 12 frames, we're going to gradually blend into the other rest field. So we start at rest 1, frame 1, that blends over to rest 2 at frame 12. And then we start blending back to rest 1. Every single 24 frames, so twice the frame length, is when these fields reset and they recalculate all the XYZ position of voxel values that are positive in density. And so the idea here is that to get rid of that distortion over time, we're resetting these fields every 24 frames, and we're just blending back and forth so that every 12 frames, we have a fresh new rest field value that isn't distorted anymore. So now on our volume visualization, we're looking at only rest 1 right now. So every single 24 frames, this is going to reset like this. And as soon as it does that, you know that it's gone ahead and recalculated all of those positions in XYZ. So we go to frame 48, it'll do it once more right here. And we know that this is working because as we go higher up in these values, the smoke gets brighter, which makes sense because the values are going up. We're going up in Y, we're going up in Z and X, and so that's why we have this little white section going on right here. But the question now is, okay, so we have this going on with rest 1, it's every 24 frames. We know that rest 2 is also going to reset every 24 frames, but this is offset by 12 frames. So, we go forward, frame 12, it reset itself. Then at frame 36, it's going to do so again. So now the question is, how do we blend between the two? How do we go back and forth so that we don't get that jarring reset happening at any point? Well, if we middle mouse our information right here, we have these guys, but we also have the detail attributes. And there's a particular detail attribute that's going to be our rest ratio. Or what Axiom calls this is our dual rest lerp that goes back and forth between 0 and 1 to blend in whether or not we're using rest 1 or rest 2. So what I did here is I isolated rest 1 and I renamed that to our combined rest position. We're going to use this field to capture the result of blending back and forth between rest 1 and rest 2. Let's create a volume VOP. And where people go wrong is by trying to use the dual rest in the dual rest solver. Truth be told, these guys were not built very well. Let's just bring everything in manually and do it ourselves. So, starting with a bind for rest 1 and rest 2. There's rest 1, that's going to be a vector. And same deal here with rest 2. We can call this rest 1 and rest 2. There we go. Okay, now what about the detail attribute? Well, here's the key. Use the import detail attributes. This guy right here. We're going to say, look at float data coming from the first input, and our attribute here is going to be the Axiom rest, well, what's it called? It's the Axiom dual rest lerp. So there we go. Axiom dual rest lerp. At this point, we can use a color mix to blend those vector positions together, like that. And that will export with a bind export to our combined rest position field. So this is going to be combined rest position, which also needs to be a vector. So as soon as we have that, what do we get? As we scrub through, it's now seamless. We don't have those pops happening, and that's exactly what we want when trying to record the position for the noises. So in the next video, we're going to take this example, we're going to take it one step further by adding some noise just to show you how this moves around. And then we'll bring it into our large, heavy scene.